Type._setter_ is used for classes, basically instances of metaclasses. Object._setter_ on the other hand, is used for instances of classes. This is totally understood. I don't see a significant difference between the two methods, at least at Python level. I notice the two use the same procedures for attribute assignment. Correct me if I'm wrong. Suppose A is an instance of a user-defined class, just a normal class. Then a .x equals ... invokes type a._setter_... which performs the following steps. Note, type a._setter_ will find _setter_ in object built-in class. 1. Look for a data descriptor in type a._row_. 2. If a data descriptor was found, call its _set_ method and exit. 3. If no data descriptor was found in type a._row_, then add attribute to a._dict_, a._dict_x equals ... With classes instances of metaclasses, the process is similar. Then, a .x equals ... is translated to type a._setter_... which performs the following steps. Note, type a._setter_ will find _setter_ in type built-in class. 1. Look for a data descriptor in type a._row_. 2. If a data descriptor was found, call its _set_ method and exit. 3. If no data descriptor was found in type a._row_, then add attribute to a._dict_, a._dict_x equals ... But object._setter_ doesn't work for classes. And vice versa, type._setter_ doesn't work for instances of A. There must be something different between the two methods. This is subtle, but true nonetheless. Presumably the two methods perform the same steps inside _setter_. What is the difference between type._setter_ and object._setter_ so that type._setter_ is limited to classes and object._setter_ is limited to instances of classes?
Type._settr_ has a check to prevent setting attributes on types like int, and it does a bunch of invisible cleanup that isn't needed for normal objects. Let's take a look under the hood. Here's type._settr_. And if we examine PyBoz object_type, we see it uses PyObject_generic settator for its _settr_, the same call that appears halfway through type_settr. Thus, type._settr_ is like object._settr_, but with some additional handling wrapped around it. First, the if type, tp_flags and py_flags_heap type check prohibits attribute assignment on types written in C, like int or numpy.array, because assigning attributes on those can seriously screw up the Python internals in ways someone unfamiliar with the C API might not expect. Second, After the PyObject_generic sedator call updates the type stict or calls an appropriate descriptor from the metaclass, update_slot fixes up any slots affected by the attribute assignment. These slots are C-level function pointers that implement functionality like instance allocation, inchecks, plus, deallocation, etc. Most of them have corresponding Python-level methods, like _contains_ or _add_, and if one of those Python-level methods is reassigned, the corresponding slot, or slots, have to be updated, too. Update_slot also updates slots on all descendants of the class, and it invalidates entries in an internal attribute cache used for type object attributes.
If you want to see more, please consider subscribing.